welcome to the lecture on controlling residual stresses in weldments. So, we will talk in more detail about the methods by which we normally control or eliminate the residual stresses in the weldments. So, residual stresses which are caused by welding may have positive or negative effect on strength of component based on their type, sign, distribution and direction. So, in some cases the residual stresses, as we had discussed, that they may be also advantageous for the product. So, but in most of the cases it has the negative effect on the strength of the component. So, and also you have the that may be the type of that is maybe compressive or tensile type of stress you may have, that way it has positive or negative, then how it is distributed, in what direction it is distributed, all these things are important to know, and basically based on that sometimes they cancel each other or sometimes they are detrimental more. So, like that it affects, and many a times the stresses in the structure will be as high as the yield strength of the material, and when combined with stresses from external loads. So, then in that case it will be going beyond your designed value. So, basically you have to have the ways for the elimination of these stresses, and you must we will be discussing about the different methods of eliminating the stresses. So, though the different methods which are used for the elimination of the stresses are like peening, then you have vibration stress relief, you have thermal treatment, thermomechanical treatment, you have a welding procedure, and then you talk also about the material and design considerations. So, basically there are large on large scale it affects the residual stresses, on large scale it affects the properties of the material, because they will be in giving you the material the tendency to fracture in the brittle manner. There may be effect on the stress corrosion cracking of the material. It will be affecting the dimensional stability of the material. Then also you will have when it is under the dynamic loads. So, you have many times you have the failure because of those loads the materials. So, so accordingly based on that these so for taking into account those effects, those ill effects of the residual stresses, these methods are being used for removing these or eliminating or maybe controlling that residual stresses. So, first among these methods is the peening method. So, as you know that this peening is normally done with hammer. So, you have what you do is, in this case the purpose is to elongate the outer fiber of the weld with the help of the mechanical hammer blows. So, you give the hammering action when you do the welding. So, mainly especially in the multi-run welds what we had discussed. In those cases we follow this practice of peening. So, this is normally for the stress relieving purpose it is used. So, when it is properly applied, it will be causing the plastic flow. So, when we apply the layers and if you do the peening, so that basically does the plastic flow in the welded zone, and it will be subsequently relieving that restraint which is that is set up so which is producing the residual stresses. So, basically that is how it will be trying to decrease the stresses. So, you can do by hand also, but you have if you use the pneumatic chisel with a blunt round top edge, in that case you can have a better control of the pinning process. Now, what it does is that the pinning process basically reduces the internal stresses of very low intensity. So, that internal stresses of very low intensity stresses, they are reduced because of the pinning process, and it will also reduce the distortion in the material. So, what happens that if you do that, so it will be also avoid any further heat treatment of successive heat treatment when normally you do the welding of thick sections. So, that way that is normally the practice in the case of welding. Now, there is one in this pinning process, one care you have to take, that when we do the pinning. So, this is basically the this is how the pinning is pinning methods are there with chisel, and you have this way also. So, what is suggested that when you are doing the multi-run welds in the first and the last weld, you do not do the pinning. So, the because of the when you if you do the pinning in the first layer, so that so what happens that when you have so if you have if you have multi-run welds, and if you so you are doing it, so you will go for many times. Now, in the first time when you do the pinning, so on the first layer, so that will be basically that pierce the weld. So, because it is delicate that time, so it will be piercing that weld, or it will displace the member sideways. So that may happen if you pin the for the first time, and then if you go further and when you are coming towards the last layer which is applied. Now, at that time also we avoid this pinning, because that may that may do the say cold working, and that also may injure the so at that time if there may be injury, so that may be splashing or so that may be there may be injury also to the worker. So that precaution you have to apply in the case of pinning. Now, we also do not do the excessive pinning because of certain factors, like if you do the excessive pinning, then there may be cold working with strain hardening taking place. So that way you will have your hardness will increase, and that will be affecting the other properties of the material. The work material may bend also because of the excessive pinning. There may be crack also in the weld, that may also happen. So, so another and one more thing, that you have to do pinning only when you are ensured that there is sufficient ductility in the material at that temperature. So, if the ductility will be less, and if you do the pinning, in that case there may be ill effects or undesirable effect on the material properties. So, so that is the pinning. Then next method is the vibratory self relief. Now, in this case the welded structures basically are subjected to vibration for stress relieving using an oscillating or rotating wave generator mechanically coupled to the part of the stress relieved. So, basically this is here we use those vibration basically to relieve the material of the stresses. So, the structure will be vibrating, at one of its natural or resonant frequency. So, that is normally seen, and it can reduce the magnitude of the peak stress. It improves resistance to the brittle fracture. So, these are the traits. So, what we do in this case, the welded structure basically all will be vibrated, and at its natural frequency. So, so plastic yielding in the region of the plastic deformation. So, in that region so that will be doing that purpose of stress relieving. Now, this vibratory self relief, it does not affect the metallurgical structure of the welds or the heat affected zone. So, it will not affect the mechanical properties also. So, like strength or toughness, so they are unaffected. So, that way it is good in that sense. You have another method, that is the thermal treatment. So, by thermal treatment means you are basically subjecting the material under some thermal treatment. You are heating and cooling in a certain fashion, so that the stress is relieved. So, it will be heating of a welded structure uniformly to a suitable temperature, then you are holding there, and then further you are cooling that uniformly. So, that basically will be relieving that result into the relieving of the residual stresses. So, that will be improving the strength and the toughness of the weldment. So, what happens that in this case the stress will be first reduced by the recovery process, and then by the permanent yielding. So, that is caused by the reduction of yield strength at elevated temperature. So, because you are increasing the temperature, so you will have the reduction in the yield strength. So, because of the recovery process, the stress will be reduced, and you have the permanent yielding also taking place. So, you will have the selection of the temperature also appropriately. You will have to have in this case, because that also the temperature to which it is heated, then the time for which it is hold. So, that basically results into the percentage relief of the welding stress, and it will be depending upon the type of composition. Then it will be how much is the time of holding. So, and what is the temperature. So, on those things it will be it will be deciding. So, in a very rough manner it has been seen that for a desirable this thermal treatment, stress relieving treatment, what is happening is that you have the suppose welded steel structure. So, you normally uniformly heat. So, you go do uniform heating to about 595 to 650 degrees centigrade, and then there you are holding. Now, for holding also there are certain guidelines. So, the holding will be based on the section thickness. So, so holding will be about 2 hour per 25 mm thickness, and then once you hold for some time, then you are basically cooling. So, cooling will be there is slowly in the furnace. So, you will be cooling slowly in the furnace, maybe to about 125 degrees C or even lower, and then it will be allowed to cool once you take it outside to the furnace and allowed to cool to the room temperature. So, that way normally that is the normal stress relief cycle which is practiced. Now, it also depends upon so if you give that time if you change the timing of holding, in that case the percentage relief will be changing. So, for suppose a for a 0.2% carbon and 1.44 manganese steel, it has been seen that if you have the different temperature and if you have the holding time which is there in the hours and this is in degree C. So, you will have some residual welding stresses which is there remaining. So, what is seen that if you do at 200 degrees C and if you do for suppose 2 hours, then it is about 33% still residual welding stress is there. But if you do at 425 degrees centigrade and if you do for 2 hours, then it is 27%. So, that is basically as you see there is a decrease in that residual welding stress when the temperature is increased and the time is kept constant. Now, if you increase the time at this temperature, if you do it for 12 hours, it will be reducing somewhat 25. Further, so there is only a small decrease in that residual welding stress value, but if you increase the temperature to 540 and if you do only for 2 hours, it comes to 11%. So, it is considerably. So, if you go to that higher temperature and if you go to suppose say 540 for 6 hours, then it comes to 9%. So, that way and if you go to suppose say 650, then and keep it for 2 hours, it will be 7%, and if you do for 650 degrees C for 8 hours, it will be about 5%. So, the residual stresses can be minimized by holding for different time and maintaining the different temperature. So, that way the stress relief treatment can be given and based on the timings you will have the different values of the residual welding stresses which is there inside the material. So, accordingly you have to take the different temperature and you have to have the different holding time, so that you can have the relief of the residual stresses. Also, you have the permanent yielding which is caused at the high temperature. So, this is because of the reduction in of the yield strength at elevated temperature. So, you will have other phenomena also may be active in those cases. So, but that is not to be discussed here. Now, coming to the different other method is the thermomechanical treatment. Now, thermomechanical treatment is basically aimed at using the thermal expansion to provide the mechanical forces that set up counteracting these residual stress system. So, there will be cancelling of the original stresses which are developed in the material. So, many a times what you do is you use some heating means. So, you have some thermal means and also the thermomechanical treatment is given to see that the stress system which is there, which is actually we know that we have studied the residual stress pattern in the welded specimen, and if you do some some heating or so. So, what we can ensure is that there may be a counter type of stress pattern that may be generated inside the specimen, and that will cancel the existing stress which is there. So, which is originally there in the material. So, what you do in this case is that you have two bands of heat move in tandem along the longitudinal direction of the weld. So, that results in the thermal expansion of the base metal. So, what we do in this case, so suppose you have a weld. So, this is your weld bead. So, this is done, and you know that when if you try to have in the longitudinal direction, if you try to see the the stress pattern. So, you will have positive here and on this side you have negative. So, now for that what you do, you are doing the heating on these sides. So, on these sides you do the heating. So, what will happen because of the heating? Now, see, you had the earlier what you see, you might have seen earlier, recall that this was the type of residual stress pattern in the case of weld. Now, if you are heating, now in that case you will have the development of the stresses, and that will go like this. So, because of the heating on both the sides. So, you are heating so you have two bands of heat. So, you are here and here. So, you use the oxy-fuel gas torches on the both the side along the longitudinal weld, and they will be moving to parallel to that bead. So, this way they will be generating a type of another residual stress because of the heating. So, that will be basically cancelling. So, what you see from here it will be it will be neglected. So, you have a negative on this side, so that will be positive. So, that will cancel. Similarly, that will also be minimized. So, this way now the position of the heat source is also in such a way it is chosen that the residual stresses which are there and the residual stresses which you are basically generating, they should be cancelling each other, or their effects should be in opposite directions, so that there is decrease or the cancellation of the residual stresses. So, in this case you have considerable reduction of the residual stress levels that can be obtained in these methods, and it has been found that maybe of the order of more than 50% the reduction in that stresses can be seen in such cases of the removal of or the elimination of or decrease of the residual stresses. Now, they do not improve the mechanical properties. So, that way so this is not going to have the substitute for the stress relief treatment. So, that is another trait of this process. So, next we have to see the other methods by which we can have the control of the residual stresses are the welding procedure and the sequence. So, in the welding procedure normally what we do is we go for the back step welding. So, what we do that in these back step welding, we take the short tack welds. So, you have the length which is normally tack weld length is normally taken as the 2.5 times the thickness. So, what we do in those cases where we talk about the welding procedures. So, in that we take that. So, the important point which is to be seen is the back step welding and the skip welding. So, in the back step welding what we do is you are doing this welding in the back direction. So, to the longitudinal direction. So, in this case what you do is you have the tack weld length which you take. So, it will be taking somewhere close to 2.5 times the thickness of the sheet which we are taking, and we are so we are and depending upon the welding speed also you will have the weld length, so spacing between the tacks. So, if it is slower, so that will be closer also. Now, the first weld which will be deposited, it will be using that back step method. So, from one tack to other in the opposite direction of the overall welding direction. So, welding direction is such. So, welding should be done in the back, in the back direction. So, in the back side. So, that is your back step welding. So, this is normally found to provide more uniform type of residual stress distribution in the case of the welding. Similarly, you have another thing is your skip welding. So, what happens that it is another method of reducing the residual stresses. So, what we do is we are skipping the portions. So, so what we do is we do for one tack length, and then we skip and then go to the next one. So, we next is skipped and then we go to. So, that way so we are so this is also very much, this proves to be very much effective in reducing that residual stresses localization or increase in that localization, and it is normally very much seen or practiced in the case of welding of cast iron. So, these two methods normally are adopted for controlling that residual stresses, and welding sequence is that you have to have the proper welding sequence so that your transverse shrinkage is basically reduced. Then you also have to focus on the material and the design considerations. So, you have to see that the material which has been selected, they have the good weldability properties. Then the important material properties which has to be considered are the melting point, diffusivity, coefficient of thermal expansion, modulus of elasticity, yield strength of material. So, these are the material properties which needs to be understood, and its effect on having the generation of the residual stresses should be known to you. So, so the design measures for limiting the welding stresses are that so these are that smallest size weld of smallest length, then fillet weld will be preferred over the butt weld. So, these are normally the material and design considerations. So, then you have the you normally prefer the division of structure into sub assemblies. So, that is also another point which is worth looking into for understanding the the distribution of the residual stresses in the material. So, and properties it is required to know, because some of the properties allow the crack to propagate more, and some may less, and depending upon the thermal properties you have the development of temperature gradient that will basically inducing the stress values, and so that way these properties also will be affecting the residual stress pattern of the material, and accordingly the measures should be taken to reduce the welding stress or residual stress values. Thank you very much.